right, so we want to talk about the quality of a statistic. And there's two things we can talk about measuring: the bias of a statistic and the variability of a statistic. All right. And one that I want to talk about in particular is when I use the sample standard deviation, we take all the deviations, x minus the mean, and we square them and we divide by n minus 1. We add them all up and divide by n minus 1, and then we take the square root of it. And you might ask, why n minus 1? And the reason is because if I just divide by n, especially for really, really small samples, we end up with a high bias. And what happens is this standard deviation misses the mark, okay? It might miss the mark and be all over the place, which is really what happens, or it might miss the mark but be consistently missing in the same direction, right? So this is like your sight is off. This is just you have bad aim and your sight is off. Here, you have bad aim, but you're at least centered around the middle. Here, you have good aim and your sight is on, okay? So you want your sight to be on. High bias misses the mark, and it means that your statistic is bad. And where does it belong? The only way to fix bias is with a trash can. Low bias hits the mark and is a good statistic. So bias cannot be fixed except for creating a new statistic. And if we haven't already, we're going to do a German tank problem. We're going to create statistics or battle statistics to see which one is the best statistic. All right. Second is the variability. Notice low variability. There's not a lot of spread. High variability. My dots are all spread out, right? See that? See the area covered by my spread? Big area covered by my spread because they're really spread out. Small area covered by my spread because they're all spread out. And so when we talk about variability, high variability means that it's spread out. Hopefully, it's spread out around the right answer right here rather than around some other spot elsewhere. Okay, you want to be spread out around the right answer, not the wrong answer. You don't want to be biased. Bias, bad. Okay, but variability is fine. Variability can be reduced with a larger sample size. I referred to this in the last video, and I need to refer to it again, and we'll see it in class over and over again. Okay, we can reduce variability with a larger sample size. Okay, we cannot reduce bias. A larger sample size, if you have a biased statistic and you just get a larger sample size, all it does is it gives you more crappy data. But if you have good statistic with low bias, then more variability gets you more accurate, right? So low bias, if I can reduce the variability, I hone in on the right answer, all right? And that's really what we're hoping for. So this is with a sample size of 100, okay? You can see that the probability comes out to about 37%, whatever the context is, I'm not too worried about. And we did 1,000 samples. So notice the number of samples isn't different here. It's 1,000 samples, 1,000 samples. But what goes from is my sample size is 100, and look how spread out it is. It goes from 22 up to 52, all right? This one right here, if I look at the same scale from 22 to 52, when I increase the sample size from 100 to 1,000, look at how much more skinny my data gets. Here, there were just over 200 towards the middle. Now there's 700 in that middle block. Look how compact and like centralized my data is. The probability of me getting a bunch here when I have 100, 22.22 as a p-hat happened sometimes. Here, I never see a 0.22 because I have a sample size of 1,000. Never happens anymore, okay? And then if I spread it out on its own distribution, you can see the larger sample size, there's less variability because instead of spreading from 0.22 to 5.2, it's 0.32 to 4.2. So there's less variability between samples. The samples look more like each other, more like the true 0.37, but it doesn't change the overall shape, right? See how it's still like this normalish unimodal symmetric distribution, okay? The overall shape doesn't change, but it reduces the variability, larger sample size. Awesome. Bias can't be fixed. Variability can be improved with larger sample size.